Hi everyone, welcome. Today we will discuss a problem in linked list to find the minimum and maximum number of nodes between critical points. So we will discuss about what exactly the critical point and how we can calculate between the distance between the minimum and maximum number of nodes between two critical points. So let's discuss more with the example. We walk through this particular example to understand the critical points. So the local minima is the kind of node with the value less than the previous and less than the next node. So here, as you can see, 5 cannot be a local minima because there is no previous node, even though 5 greater than 3. And this can't be a local maxima because there is no previous node. So if you take it to 3, 3 less than 5 and 3 greater than 1, right? So this can't be a local minima or local maxima. Okay, let me put the indexes for references because we need to calculate the minimum and maximum distance between the two nodes of local minima and local maxima, right? Okay, let me come back to 1. So 1 is less than 3 and less than 2. So this can be local minima. So if you come to 2, 2 is greater than 1 but 2 is less than 5. So this cannot be a local minima or local maxima. So come back to 5, 5 is greater than 2 and 5 is greater than 1. So this can be a local maxima, right? Because it's greater than its neighbors. Come back to 1, 1 is less than 5 and 1 is less than 2. So this can be a local minima. If you take it 2, 2 cannot be a local maxima or local minima. So our indexes are, which are critical points here, 3, 5 and 6, right? So the minimum distance is 6 minus 5 equal to 1 and the maximum distance is 6 minus 3 equal to 3. So this is the final answer we need to send as a output. I hope this clears the critical points. So let's walk into the actual solution in C Sharp. Let's start writing the code for this particular problem in C Sharp. So this is the public class which defines the list node with the value and the next for next node for the list node, right? So I think this is most probably everybody is familiar with how the class look like with the list node. Let's try to find the critical points first and then find the minimal distance and max distance between those critical points, right? So the first condition to check, I would say base conditions to check whether there is sufficient critical points to find, right? Because if there is no, if there is a critical points less than the minimal ones, then we should return -1 and -1, right? So that is the initial condition we want to check. Like if the list has less than 3 nodes, then obviously it is like return -1 and -1 as per the problem statement. Let's say if add is not null or add dot next is null or add dot next null, then it will be -1 and -1. So that is a base condition where we want to check whether the list node has sufficient number of nodes to calculate the critical points and get the minimal and maximum distance between those critical points, right? So as we need to list critical points, I'm just declaring here the list to store the information about critical points. So as I discussed in the previous example, so I want to store the indexes here so that it can be used for to calculate the minimum and maximum distance. So I want to have 3 pointers. One previous is head and current is add dot next, and next is add dot next dot next. So I will have index I want to with the traverse of the list link list node. I want to increment the index to calculate the means verify the whether the particular node is minimal minima or maxima, and if it is minima or maxima, then I want to capture the index to calculate the distance, right? So the next step is while the next is as long as the next is not equal to null, then this is the condition to check local minima or local maxima, right? So how it will be, right? So let's say if the previous let's say the current value is greater than the previous value, and the current value is greater than next add value, right? If the current value is if the current value is greater than previous value and the current value is greater than next value, then it will become local maximum. Or if the current value is less than the previous value and the current value is less than the next add value, correct? So I'm just trying to see this. Then I want to add this particular node particular index into the this particular list, right? So critical points dot add, so it is index, and so it is general practice to move the previous to current, and the current to next, and next will be current, sorry, next will be next dot next, and I'll increment the index for calculation, right? So once this is done, so this critical points list will have all the critical points indexes stored as a list. So next step, calculate the distance, right? So far we calculated the critical points. Like, with this loop, we are trying to capture based on these particular conditions whether its previous value is greater than previous value and value is greater than next value, or if value is less than the previous value, or and value is less than the next value, then we're capturing the indexes and storing this particular list. Then the calculated distances. So in min distance, I'm storing a variable. So as a standard practice, so always the minimum value will assign the max value to get the actual minimum distance, right? So the int max, so this will be, if you remember the previous example, it is 6 minus, what you call 6 minus 3 means the first and the last, sorry, the last and first, right? So it will be critical points dot count minus 1 minus critical points minus 0 means the first value, right? And we need to calculate the minimum distance. So if there is multiple values, then we want to calculate the minimum distance here is equal to math.min minimum distance and critical point I minus critical point I minus 1, right? So that's why the index is started at I equal to 1, right? Then once the calculation is done, we will return min distance and max distance, right? So we're checking for the base condition. If there's no sufficient nodes to calculate the critical points, then we return minus and minus 1. Then we declare as the list int to capture the critical points, and there are two pointers, one point to the head and add dot next as current, and add dot not next dot next as the next, and also have the index variable to capture the index to count and increment based on the traversal. I think maybe if the critical points are not there in this case, like even though there is no much critical points, even though there's more than 5 to 6 nodes, even sometimes there will not be sufficient critical points, right? I think that condition has to be checked before calculating the minimal distance, right? I think so that we will not return any other values like other than minus one as per the problem statement. Okay, something wrong. Let me see. Okay, I'm missing this. Awesome. Okay, let's talk about the time and space complexity. So that is a crucial aspect after solving a problem with the solution, so we need to calculate the time and space complexity, right? So as we can see, we are traversing the linked list once, so it will take order of n time, where n is the number of nodes, right? And also identifying the critical nodes, each node involves constant time comparison to determine whether it's a local minima or local maxima. So it will be order of n, so that overall time complexity is order of n. When it comes to the space, so we were using a list of int to store the n critical points, right? Like, so if it can be n or it can be less than n, so we are storing into list, and others variables are kind of constant space, order of 1. So overall I think it will be order of n if all means, even though there are not few points are not critical, it, if let's say n minus 1 or n minus 2 or n minus 3, still it's order of n. So the overall space complexity is order of n, and the time complexity is order of n. So there are similar problems which, if you're interested to solve, there are like detecting the peaks and valleys in a linked list, identifying the changing trends in a linked list, peak finding in a linked list. These are the similar problems where we can solve to understand more about finding the minimal and maximum in linked list, and to find those kind of problems. So that's all for this video. I'll see you again in the different video. So thank you.